So here what we are doing in the problem is that we are making two lamps on at a time in a sequence form. Okay. So it is L1, L2, then L2, L3, then L3, L1, then repeat the process. Okay.
Yes.
So now let me take
The
first
question.
timers.
Okay.
Question you didn't understood.
No, understood, ma'am. In the question, L1, L2 should on after 5 seconds of delay.
No, no. L1, L2 should on. Then after 5 seconds, L2, L3 should on. After 5 seconds, L3, L1 should on. Actually, there was no space. So I wrote it down.
Okay.
I forgot to mention the comma.
Okay.
Got it now?
Yeah, got it.
Should I do it?
No need.
What about others?
Madam, please explain.
Okay, I'll explain them. So first we take switch. So I'll go first for timers. Since it is a sequence of three steps, like there is a three-step sequence, I will be using three timers. Okay. So now these are three timers I have taken. Okay. We'll go for repetition afterwards. Now, what is the first condition? L1 and L2 both should be on, correct? So I'll take 0.0. Then T0. Then output and name it as L1. Okay. So when L1 gets on, simultaneously L2 should also get on. So again, I'll take 0.00. Here I'll take T0. Then output 0.1. Okay. In the next condition, we have L2 and L3 should be on, correct? So now L2 should on again, right? So what I'll do, I'll take T0, then I'll take T1. And similarly, L3 should be on. So I'll repeat again the same condition. Okay. Next is again L3 and L1 should be on, correct? So here I'll take T1. Then I'll take T2. L3 is on now. Simultaneously, I have to make L1 also on. Now this will on for 5 seconds in the sequence. Okay. Now I want to repeat the process. Therefore, I'll take one more timer. And I'll take here 3. Okay, any confusion? Any confusion? Is it okay?
Okay, madam, no confusions.
Okay. So you can see the output now. L1, L2 is on. Now L2, L3 is on. Now L3, L1 is on. It's off for 5 seconds. Again, the process will repeat. Okay? Radhakrishna,
Okay.
is it okay? Any confusion?
No, ma'am.
Okay. What about the second one? Is it okay? Will you people try it? Okay, now I want to repeat this process only for 5 times. Then what should I do? Can anyone tell me how should I do that?
You need to add counter, madam.
Okay, I will take the counter
Wait.
PNT P0 #5. What should be the counter input?
T3 is input.
Type 3.
T3.
Yes.
Yes, madam. 100.02 also okay, madam.
100.02 also is okay. Okay, I'll give T3. Let's see one by one. Now, where should I use the counter output? Where
The
should I
first
take
strum.
these? Okay.
Which one, madam?
Not
Which one?
Parallel, madam.
here NC,
Parallelly.
ma'am.
Parallelly.
NC, ma'am. After 0.00,
NC.
we need to use it is as NC.
Okay. Parallel or series? Someone is saying parallel.
Series only, ma'am.
Series only. Okay. Others getting it?
Before T3.
That's fine.
Before T, after
Parallel.
Wait.
ma'am,
Okay, where should
not
I
here,
place?
ma'am. Before, after 0.00.
Okay. Is it fine? Is it okay now?
Yes. After here, ma'am, bottom side. First strum
Bottom
for
side.
L1 lamp. For L1
There
lamp is there,
also.
no?
There
Yeah.
also.
Yes, sir.
Okay. Here, after T0 or after 0.00. Here, where I have to place?
No, after 0.00. Input, after the input.
Okay, the input I have to place. Give me a minute. This parallel, where should it come? Here I have to place C0.
Yes, ma'am.
Okay. Now this is my T2. Parallel connection, where it should come? Here or here? Here or here?
Yes, ma'am. After T0.
After T naught.
Okay.
For second rung also we need to add, ma'am, that one.
Second rung also.
Yes,
Second rung
now
also
it
it is getting on. Why it is getting
Mm.
on in the second rung?
Here,
It should get off, right?
no, ma'am, here
If
input is there, no,
I
input, we have input. Push
yes.
button is in on condition and timer T1 off.
Okay.
Then we'll get the output.
Here
So
also we
in
have to
between,
repeat.
yes, in between, in
In
push button
between.
and timer. Yes, push button and timer 1, no, timer 0.
Here, I'll
Yes.
tell you. Wait. Now, placing it here in between on this side is same. Okay? There is no difference. Once there is no current flow, it will avoid wherever it is. It need not to be placed in center. It's your wish.
Yes, yes.
Next, here it is actually not required. Okay? So if I take, yeah, here it is required. So simultaneously, I have to take it here also. Let me copy this. I can avoid that. Okay, it will remain same. And this much you guys understood, right?
Yes, ma'am.
Let's say I want to stop the, like every 5 cycles, I have to give a 10 seconds delay. Then again, I have to start the process. So what should I do for that? Now it is cycle is repeating for 5 times. After 5 times, it has to take a break of 10 seconds. Then again, it has to start. What should I do now?
Need to reset the counter, ma'am.
How are we going to reset the counter? Now I'm using a switch.
Yeah, we are giving 10-second delay, right? Need to use that timer input as
Timer output.
as a input for
Yes.
this.
So here I'll be taking counter output, okay, to the timer, and I'm giving a delay of 5 seconds, and we'll change this time to 20, okay, so that the process runs faster. I give the counter cycle as 3.
Madam, not seeing your screen.
Is my voice is audible?
Yes, madam.
Okay, thank you. Any more changes are there in the program? That's all. Should I add anything extra? No, right? Let's simulate this
No,
one.
ma'am. Okay.
Okay, the process is repeating again. Understood? Any confusion? Got it?
Yes, ma'am, got it.
Okay, should I make the question so that like for this one, or is it okay if it is like this only? No need of writing something, right?
No need.
Okay, fine. So this finishes timers and counters. Any confusion still?
Madam, this problem, why timer required, madam? Timer 5.
Timer 5 last, I gave a condition, right? I want to stop the process for, see, it is repeating for 3 times. It has to take a break of 5 seconds. Then again, it should continue. Okay, it should take a break of 5 seconds. For that reason, I have given a timer 5.
Okay, madam.
Now for this problem, I had given 2 extra conditions as well, right? One is counting for 3 times. Then again, stopping it for 5 seconds. Then again, repeating the process. Okay.
Okay, madam.
Okay, fine. Shall we go for conversions? Shall we start?
Okay, madam.
Okay. So, you guys have any idea about conversion, data conversion,
No, madam.
binary to decimal, decimal to binary? Anyone having idea? Okay, whenever we speak about computer language, so computer always stores in binary format, that is zeros and ones. Okay, so if we speak in terms for the storage purpose, we'll speak in terms of hexadecimal numbers. Okay, decimal what we understand, whereas the system will be understanding either in hexadecimal or binary. So it is important to know the conversion, like how exactly the values are storing. Okay. So there are totally 4, 5 types. It depends. Okay. Majorly, if you want to speak, we have first thing is decimal. Then comes binary, octal, and hexadecimal. So binary mean decimal means it is 0 to 9. Okay. Binary 1, sorry, 0 to 1. This 0 to 7. Octal. Octal represents 8. Okay. Hexadecimal represents 16. So it is 0 to 9 and A to F. Okay. So now everyone knows about decimal. Then is binary 0 or 1. Next comes the octal. Okay. Then is the hexadecimal, which till decimal it will be 0 to 9. After decimal for 10, 11, 12, 13, 14, 15, it is A to F. Here A represents 10, B represents 11, C represents 12, D represents 13, E represents 15 and F represents, 14. E represents 14 and F represents 15. Okay, it is 0 to 15. Now here in Omron PLC, we have two types of conversion. One is binary to BCD, BCD to binary. So BCD is nothing but binary coded decimal, which is 0 to 9. Okay. But when we are doing conversion, we'll not take in form of zeros or 1. We'll be taking it in the form of hexadecimal number, because here we are using a 32-bit memory size, not 32, it's 16, 16. So we are taking it in 16 to the power of 16, okay? Since we are taking a 32-bit, that means I have 4 bytes, correct? So I'll be having a 4 bytes of data. So if it is a 4 bytes of data, means you have to represent zeros and ones 32 times. So if I take a hexadecimal number, I'll be representing only 4 digit, like 4 numbers I'll be mentioning. So because this hexadecimal number, the 16 number will be making uh, 1 byte, 2 bytes. Okay, understood?
Ma'am, last thing not understood. Not
Last thing, okay.
understand.
Hexadecimal is 0 to, now let me represent, wait. Now see, this is a 2 bytes of data, okay? Each one is representing the 1 bit. Now this is a 2 byte of data. Okay, this whole thing is a 2 byte of data. Now here, if I want to represent it in PLC, it will be very lengthy, correct? To avoid that, we'll be using it in hexadecimal form. Okay, 1 second. Now it will make a group for a nibble. Okay, so now this 16 numbers, you can represent bit by 4 numbers. Now, if I convert this binary to hexadecimal, this is 3. Sorry, this is 2. This is 3, 0. This is 5. Okay, it is a hex number. So, for the representation purpose, this is in terms of PLC I am telling. Okay, so to make it easier, we'll be converting this binary to hexadecimal. Okay, but we'll not tell it as hexadecimal to BCD, but we'll be telling it as binary to BCD. Okay, should I teach the conversion as well? How we convert binary to decimal, decimal to octal, octal to hexadecimal? No need, right?
Ma'am, give one examples. Only one example.
One examples. Okay.
Yes.
Sorry. This much you guys understood?
Understood.
Okay. Now first we'll do decimal to binary. So let's take a number 125. Okay. So this is a binary number. How I'm going to represent it in decimal? Okay. So to represent it in decimal, the base value for binary is 2. Okay. Binary
2.
means 2. I have to divide this number by 2 until I get the remainder as 0. Okay. So
Okay.
now okay, fine. So now if I divide this number by 2, what will be the thing? Answer I'll get here.
62. 62. Carry 1.
62 carry 1. So I'll represent carry 1 this side. Okay. Now if I
Okay.
divide 62 by 2 again.
31.
Okay. What about carry? Reminder?
0.
0.
Carry. Okay. Okay. Sir.
Now if I divide 32 again by 2, it's 16. It is again 0. Now if I divide 16 again by 2, it will be 8.
Ma'am, that is 31, right? Not
Sorry,
32.
31. This is 1, 16. Oh no, wait. It's 15. Okay. I only got confused. 7. Again, 1. 2. If I divide 1 by 2, it is 0 and the remainder is 1. Okay. So now what I'll do, I have to represent it, right? I'll take it, the values of this one in the reverse order. Okay. I have to read like this. Therefore, I'll get the value as, I think I've done mistake somewhere.
Madam, 31 0 carry, madam.
31 0 carry. Correct.
Yeah.
Okay. So it is 1 1 1 1 1 0 1. So now this is the conversion. Okay. This is the value of 125 in binary. Okay. Understood?
Yeah.
Any confusion?
No.
And carry over 31. Okay. Okay. So let me now we'll do it from binary to decimal. Can anyone guess what we will do in binary to decimal? So now we'll take the same one. 1 1 1 0 1. How are we going to convert this from binary to decimal? We have to take the power of 2. That is, I'll come from this side. Now 1 into 2 power 0. Okay. Now what is 2 power 0?
1.
1 second. Now 2 power 0 is 1. 1. 1 into 1 will be 1. Correct. So now 0 into 2 power 1. So we have to do until we have to check how many terms we have. 1, 2, 3, 4, 5, 6, 7. So it will go from 2 power 0 to 2 power 6. Okay.
6.
So now 2 into 2. Sorry. 2 power 2. 1 into. Someone please tell me the final value. Okay, after conversion. 1. Okay. Now again once. Two raised to 3. 1 star 2 raised to 4. Right. Okay. Now what is 2 power this one? This value? Will come from this side. What is 2 power 6?
64.
64 plus 2 power 5?
Yes.
32,
32.
8.
32.
I wrote 32, 16, 8, 4, 4 plus 0 plus 1.
4 plus 0 plus 1.
Okay. 64 plus 70, 80. 1, no, 112 plus 125. I get 125. Is it okay? Now this is binary to decimal. One second. Any confusion? Is it okay? Okay.
Okay.
This is binary to decimal to binary, binary to decimal. Now, if I want to convert it from octal to binary, sorry, octal to decimal to octal, how I have done it in the binary? One second. Here, now whenever I convert any form from decimal to any other form, okay, Let's say I'm converting it from decimal to binary, then I will divide it by 2. If I'm converting decimal to octal, then I have to divide this number by 8. Okay. If I'm converting decimal to hexadecimal, then I have to divide it by 16. Okay. Understood?
Okay. Understood.
Yes, ma'am.
If I take decimal to octal, which should be 125 divided by 8. So can anyone tell me what will be the value? You have to divide it by 8 until you get 0 as your answer. And okay.
One.
How much will get? What is the answer?
175.
170? Okay. Radhakrishna, what is the answer?
175.
I'm not able to hear it clearly. Maybe because
175, madam.
175. Correct. Okay. Will be 175. So if same number, if I do it for decimal to hexadecimal,
Yes, ma'am.
how much will be the value? Now you have to divide 125 by 16.
Sixteen, 15.
How much did you got?
730.
Huh? In hexadecimal, can you represent 13? Are you representing 13 in hexadecimal?
713.
713. How are you representing it in hexadecimal? You have only 0 to 9 numbers, then from A to F. So when I divide 125 by 16.
Seven D.
Remainder is 7. This is correct. Now 0. This is 30. But I'll represent it in hexadecimal as B.
D.
Okay.
13D or only D, ma'am?
Sorry. No, only D. It's 7D, right?
Divided by
This you will get 7. Here you will be 13. That I'll be representing it as capital D. Okay. So here it is 0. This will be 7. So again, I have to take it in the reverse order. So if I convert decimal to hexadecimal, then it is 7D. Okay. See here. Only the numbers will be from 0 to 9. That's all. From 10 to 15, we have to represent it in alphabetical order. That is A to F. Okay. Got it? Now A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 50. Okay? Okay, is it fine? Now we'll go for decimal to octal. Sorry, binary to octal. So how are we going to convert this one? So 4 to 1. Can anyone tell me how are we going to convert this one?
So 8421 concept can implement.
8421 code. If you add 8421, you will get 15. Can you use it for octal? So for binary to octal, we'll use the code 42421. Okay. See, in octal, it is 0 to 7. Okay. So if I take 2 power 0, 2 power 1, and 2 power 2, only these three numbers, if I add, I'll get 7. Okay. So what will I do is that I will group them. I'll group these numbers in a group of 3. Okay. So I'll group this, and if any single digit is left, I'll be appending 2 zeros. Okay. Now if I convert, this will be 5, this will be 7, and this will be 1. It is nothing but 175. Okay. Is it okay?
okay.
Mallikarjun understood?
Yeah, ma'am, understood.
Okay. Now for binary to octal, sorry, hexadecimal, I'll group it for 4 numbers. Okay, not 3, 4. And I will follow the code of 8, 4, 2, 1. Okay, 2 power 0, 2 power 1, 2 power 2, and 2 power 3. If I add these three, I'll get a value of 15. Okay, so now when I group it for 4 numbers, and I will append a 0 because it should be a group of 4. So this is 8 plus 4, 12, 12 plus 1, 13. Therefore, I'll write it as 3, and this is 7. Therefore, the conversion of 111101 is 7D. Okay? Any confusion?
No, madam. No.
It's clear, right?
Yes.
Okay. So now this binary to BCD and BCD to binary, we will be using it in the software. So the command goes like this. Okay. BCD, if I say BCD, I'll be having a source and a result. Okay. So I can represent it as this is a binary to BCD conversion. Okay. This command BCD is for binary to BCD conversion. Now here S is a source. So now you have to give a value which you are going to convert. Okay. And R is the resultant. So where you will be storing the converted values. Or you can say it as a destination. Now, for here, when we are giving it in the Omron PLC, I have to give it as BCD, D0, D1. Okay. So D0, D1 are the data registers. Okay. In which you will be storing the value. They are like a data memory. Okay. The size of this register are in bytes. Okay. When we were using 10, 10.1, 10.2, it is a bit memory, but this is a byte memory. Okay. Any confusion?
Ma'am, difference between byte memory and bit memory. What, ma'am?
1 bit. That's all. 1 byte will be 8 bit.
Byte memory, bit memory.
Only this much is the difference. Okay. Here, whenever you encounter, you have a arithmetic or alphanumeric values, you want to store them, we'll go for this register. If you want to store only high or low condition, we'll go for a bit memory. Okay.
Okay, okay.
Understood?
Okay.
And one more thing, when we were using the timers, we were giving this direct hash value, right? Hash 5.
Yeah.
The constant value we were giving. And this constant value we cannot change while we were running the code, correct? Can
Yes.
we change this value? But if I use it instead of this using hash 5, if I use a register D0, I can, if I feed the value of D0, anytime while I'm running the code, I can change the value. Okay, that is the advantage of using register. This address memory type. Okay, I can change my preset value anytime while running the code. I need not to stop running it, then change the value, then again compile and run it. It's not required. While the program is running, that time only I can change the value. Okay.
This is
Understood?
only for, yeah, this is only possible for registers, right? D registers.
Yeah, D registers. Any confusion? Okay, fine. Tomorrow I'll show how to execute it in the software. So we'll stop here today. If you have any confusion, please let me know.
Madam, deregister means what?
It is a data register. If you want to store numbers, let's say if I want to store a value of 25, or let me say I have to store a addition of two numbers, where I will store? I need some register, right? Or I need some block. I need something to store that value. So here we'll call it as data memory, and that nomenclature given to that as D0. So I am telling it as a data register. Okay.
Ma'am, D0 is common for bit memory and byte memory.
No,
Or
bit memory is 10, 0, 10, 10 to 99.
10 to 19.
10.002, 10.15, that goes till 99.002, 99.15. Okay. See, we used 0.0, correct, memory. Then we used 100. The rest in between the num is allocated for memory addressing. Okay.
Okay.
Any other doubts? We'll stop.
Madam, actually input address 0.00, how much means maximum total
It
16 input?
No, it depends upon the PLC which you're selecting.
Ah,
Okay, let's say if I'm taking a Omron fixed type PLC, CP1E model fixed type PLC, I'll be having 6 inputs and 4 outputs. So the address varies from 0.00 to 0.05. Okay, so 10 IO. If I take a combination of 20 IO, then it is 12 inputs, 8 output. Okay.